This is Mr. Precella picking up after our short break. We had discussed applications of functions in Math 1324 on our first video, and this is going with our first assignment. And we've gotten up to discussing quadratic functions. We discussed linear functions in part 1. We said with the quadratic function, there's got to be an x squared. It needs to be in the form ax squared plus bx plus c. And graphs of quadratic functions are called parabolas, U-shaped figures. They open up when the number a is positive, down when the number a is negative. And the turning point on a parabola is called the vertex. And to find that turning point, we use minus b over 2a. We're getting ready to do problem number 13, which I'd sort of already started right here. Well, I guess I'll let you see it, the whole thing. A researcher in physiology has decided that a good model for the number of impulses fired after a nerve has been stimulated is given by y equals negative 1x squared plus 20x minus 40. You'll notice where I sort of started this problem, where y is the number of responses per millisecond and x is the number of milliseconds. When will the maximum firing rate be reached? Well, this is a quadratic function, and a is the number negative 1, and then this less than 0 means a is negative. If a is negative, the graph opens down. So if it's opening downward, there must be a maximum at the vertex. So that's what I'm deciding here. The maximum must occur at the vertex. So I'm doing minus b over 2a. b is 20, so minus 20 over 2 times negative 1. That would be negative 20 over, ooh, my writing's terrible here, over negative 2, which would be a positive 10, and so it would go right there in that box. The maximum number of impulses fired occur at 10 milliseconds. Now, to find the maximum firing rate, once you find x, you've got to find y. And how do you find y? Well, you plug in. Be careful when you're plugging in. Y equals negative 1 times 10 squared plus 20 times 10 minus 40. Notice the way I wrote in negative 1x squared. Hopefully it's clear to you this negative is not being squared. You square the 10, then multiply by negative 1. So this would be negative 10 squared is 100. 10 squared is 100 times negative 1 is negative 100. 20 times 10 is 200 minus 40. So 200 minus 100 is 100, minus 40 is 60. So the maximum number of impulses per millisecond is 60. Oh, wow. Already they're cutting the lights off. Okay? Let's do another example. I have one right here. Cut it so we can see little graphs right there. Okay? A bullet is fired upward from ground level. Its height above the ground at t seconds is given by, is this a quadratic function? Well, yes it is. A is negative 16, B is 1208, and you'll notice with a quadratic function, this plus c, that's the constant. B or c could be 0. And so here c is 0. So it is a quadratic function. So you can sort of figure out where this is going from. This is a parabola that's opening down because the first number is negative. So to find the vertex, t T equals minus B over 2A minus 1208 over 2 times A. I'm not going to show that plugging in there. I'm just going to do that in my head. 2 times negative 16 is negative 32. And I'll punch that into my calculator. Negative 1208 divided by negative 32. Well, negative divided by negative is positive. 1208 divided by 32 is, let me see, minus B over 2 times A. Let me find my calculator. Okay, 1208 divided by 32 is 37.75. The maximum height reached by the bullet is, see, T is the time. That's how long it takes to get up to this maximum height. So it's not asking for the time it takes to reach its maximum. It wants you to go straight on and do what with this number to get the height? Well, plug in here. So plug 37.75 in for T. So let me see, where can I write that? I'm going to do it right here. Move this up. H negative 16 times 37.75 squared plus 1208 times 37.75. Negative 16 times 37.75 squared plus 1208 times 37.75. Let me see if I can put this calculator under there so you can see it without too much glare. Okay, negative 16 times 37.75 squared plus 1208 times 37.75. That's 22,801. So that would be the answer to the height. Okay. Then it asks not what you might be thinking, not for this time. Find the time when the bullet hits the ground. Well, the bullet started off at ground level. These parabolas are symmetric. If it took 37.75 seconds to go up from the ground level up, it's going to take the same amount of time to go down. So to answer this, I'll say 2 times 37.75. 75.5. So it's taken 75.5 seconds for it to go from ground level, reach its maximum, and back to ground level. Okay? Let me see if I can find another one of these for us to do. How about number 15? Or supply and demand. Let's see. And we were working with supply and demand curves the last time on the last video. And we said market equilibrium occurs when supply equals demand. But let's see, I don't see it saying the word equilibrium here. Suppose the supply and demand for a certain textbook are given by supply. So this takes the view of the businesses, the producer. That's the supply curve. And the demand curve. It tells you, it relates the price and the quantity demanded. Here it relates the price and the quantity supplied. Where P is price and Q is quantity. Find the demand and supply quantities at a price of $5. Well, first thing, the number of books that are demanded at a price of $5. That means put the 5 in for which variable, P or Q? Well, this is a price. You go to the demand curve, put a 5 in for P. So we have 5 equals negative 1/3 Q squared plus 20. To solve this for Q, I'm going to subtract 20 from both sides. 5 minus 20 is a negative 15. Then I need to do something to get rid of this fraction. I want to get this Q squared by itself. What I'll do is multiply both sides by, just multiply by 3 will get rid of the fraction. I'm going to go ahead and multiply both sides by negative 3. Multiplying by negative 3 will get rid of the negative and the fraction. If I multiply both sides by negative 3, negative 3 times negative 15 is a positive 45. Negative 3 times negative 1/3, can y'all do that arithmetic easily? The 3's would cancel. Negative times negative is positive. So we have Q squared equals 45. And Q would be, to get rid of the square here, you just take a square root. Ooh, that's sort of messy. This says Q equals square root of 45. So let's see. On my calculator, I'll go second square root 45. 6.708. Now we're told to round to the nearest whole number. So we'll round that, if I'm rounding to a whole number, 7. So the number of books that are demanded at a price of $5 is 7. So there'll be people wanting to buy 7 books when the price is $5. Now let's see how many the producers will supply if the price is just $5. If the price is $5, how many books are they willing to make and put out on the shelf? Okay, so let's plug a 5 into the supply. I'm now doing the number of books supplied. 5 equals 1/3 Q squared. Multiply both sides by 3. Get rid of the fraction, so we have 15 equals Q squared, and take square root, so we have Q is the square root of 15. The square root of 15, my calculator says the square root of 15 is 3.872. Dot, dot, dot. We're told to round this to the nearest whole number. So that would be 4. So 7, the consumer's going to be demanding 7 books, whereas the suppliers are only going to be providing 4 books. So there's going to be a shortfall of books, which means what are they going to need to do? Maybe the people in the bookstore are going to decide, we better raise the price a little more than $5. They're trying to find that perfect equilibrium where they don't have any excess stock on the shelves and that they eventually have to just lower the price and get rid of. And they don't want too many consumers demanding the object and them having to say, we don't have it. Okay? That market equilibrium is the desirable spot. Let's see. Number 14. Oh, it's the same thing, except the number's 25. Plug 25 in for P, and then 25 in for this P. See, number 17. Looks like 17 and 18 are both the same. Maybe I'll do 18. That has the bigger number. Okay, I just printed out these problems. you should find homework problems similar to these that I'm doing here, okay? Except you can't decide when you're doing the homework if there's two that are the exact same type. You can't do like me and say, well, I've done that. But you're getting graded, so you're going to have to do both of them. Let's see, number 18. Find the equilibrium quantity and price. I'm doing this one right here. For the commodity whose supply and demand functions are given. 17 and 18 look exactly the same but with different numbers. To find equilibrium, you set supply equal to demand. So I'm doing this one right here. So I'll set supply equal to demand. So 20Q equals negative Q squared plus 8,000. To solve this equation, I'm going to get a 0 on one side. So we have Q squared plus 20Q and then minus 8,000. And then that's the first time I've done something. I'm about to do factoring to solve this. I remember doing factoring at some time in your life. I'm going to need to write out the two set of parentheses. Oops. So write out the two sets of parentheses. And to factor, I just do a reverse FOIL approach. We're not going to be doing a lot of factoring, but when it comes up, okay, what can I put here and here? That'll give me Q squared, or Q times Q. And then I need numbers that multiply together to give a negative 8,000. Well, oh gosh, in algebra classes, I'll generally start writing out the pairs of numbers that multiply together, like 1 times 8,000, 2 times 4,000. But that in algebra, generally we have smaller numbers than this. So let me just think. I need numbers. What pair of numbers? I guess 80 times 100. Those multiply together to give 8,000. And can it? So 80 times 100. Now the 80 times 100 needs to multiply to give a negative 8,000. So in algebra, I tell my students if that second sign is minus, then you need one plus and one minus in here. How do I arrange them in order to get a positive 20? Well, I would need the 100 to be positive and the 80 to be negative. You can FOIL that out. We'd have Q squared, then a plus 100Q and a minus 80Q. That's giving you a positive 20Q minus 8,000. Now set each one of these factors to 0. Q minus 80 equals 0, and Q plus 100 equals 0. And solve them. Ooh. I'll add 50, so I'm getting, looks like two answers. Q equals 50, or Q equals negative 100. Well, Q is standing for quantity. Which one of these numbers wouldn't make sense for a quantity? Well, you can't have a negative quantity. Okay? So what we found was quantity. It's called the equilibrium quantity. Q equals 50, so you plug 50 in there. At the price, how to find the price? You're going to plug 50 into which one of them? It doesn't matter. They should both give you the same number. So I'm going to plug it into the one I can do easily in my head right here. 20 times 50. 20 times 50 is what? Well, let me see. Oh my goodness. My 80. What, do y'all see that? I messed up. Where did I get a 50? I can't even read my own writing. This isn't a 50, is it? It's an 80. So let me make that change. Now, this is one of those problems with these videos. Can't just go back and undo it. You know, see, I couldn't read my own writing. 80, I changed to 50, but it should, hopefully you caught that. So it should be Q equals 80, 80 right there, and then 20 times 80, 1600. So they should set the price at $1,600, and they can produce and sell 80 of the items at that price. Because I messed up there, maybe I better go ahead and do number 17 also. Let me see if I can do 17 without miscopying something. Okay? But sometimes that'll happen. Hopefully not too much. Let's see. I'm going to do problem number 17. Same type of problem. I'll set supply equal to demand. 80Q equals negative Q squared plus 4,800. I'll move everything over. So I have Q squared plus 80Q, and that's going to be a minus 4,800 equals 0. So to factor this, Q, I need a pair of numbers. Let's see, 40 divides into 4,800, doesn't it? 40 times 120. Oh yeah, that I can do that. 40 times 120. I would make the 120 positive, the 40 negative. Here's where I messed up on the other one. Setting each one of these to 0. This is where I miscopied the 80 and became a 50. I get Q equals 40, or Q equals negative 120. Can't have a negative quantity. So Q is 40. Plug in to either one of these to get P. So P, I'm going to do this one. 80 times 40. Ooh, that orange is so dim, isn't it? 80 times 40, 3,200. Okay. So I did that one without messing up at least. Now, let's see, 19 and 20, ooh, running out of time. 19 and 20 are the same type of problem, so I'll do number 19. Unless I mess up on it, then I'll do number 20 also. Okay? So let's see. Number 19. Is that feasible? Oh, we're leaving the supply and demand, and what is it saying here? We're given a revenue function and a cost function. We're told that these are valid only for x's between 0 and 100. So for some reason they can't produce and sell more than 100 items. Maybe there's a assembly line, maybe just some sort of restrictions. They can't make more than 100. Find the number of units that must be produced to break even. Well, break even occurs when revenue equals cost. So 200x minus x squared. I'm setting the revenue equal to the cost, and I'm going to write it with everything over on one side. In that form, I'll write the negative x squared first. Now I'm subtracting 40. So 200 minus 40, that would be a 160x. and I'm subtracting 5175. Now, I could draw my two parentheses and start factoring, but whenever I factor, I always like that first number to be positive. So, if I just divide straight through by -1, I would have x squared minus 160x and a plus 5175 equals 0. X and X, and now you need a calculator to sort of play around. It's got to be two numbers that multiply together to give 5175, and then they've got the second sign is plus 2 of the first, so there's a minus and minus. So these two numbers need to add together to give 160. 5175. 5175 is not divisible by 50. Notice it didn't go into it evenly. Let's try something close. Another number that ends in 5. Maybe 5175 divided by 45. 115. Will that work? Did I get lucky? 45 times 115. Those numbers will multiply together to give 5175. And do they add together to give the 160? Yeah. So, okay, I have this factored correctly. Set each one of these to 0, so I get x equals 45, or x equals 115. But there's only one answer. Which one are we going to mark out? Well, we got to take into consideration x can only be between 0 and 100. They can't produce more than 100 items for some reason. So you're going to mark out the 115 and put a 45 there. So these numbers get a little big. If you have a calculator, I think it's that's probably the best bet. Just sort of play around with it. If you click on View an Example, they might be using the quadratic formula on this. I'm not sure how they'll do it. But you have a calculator, and you should. Then just play around with the little multiplication, I should say, and addition to find the pair of numbers, like I did. I first asked, well, does 50 go into it? No, but what about something close to it? Okay. So number 20, I have one more example like this, but we're out of time. I've spent enough time on assignment 1, so sort of went through working out problems similar to what you'll see on your first assignment. So good luck with the course, and stay caught up with me. You should be watching, if you're in the online class, you should be watching this video very early and start the homework. Don't wait until the very end and then try to do it all at once. So, thank you, and bye-bye.